So we already talked about prisms yesterday, 2 big B plus big PH. We talked about how that is derived from the fact that, first of all, a prism has 2 bases. So big B doesn't stand for base, it stands for the area of that base. And this was a triangular prism. I don't care if it's sitting on its rectangle. The triangles are the bases because they're the opposite / parallel congruent shapes. So if you use the rectangle as big base, you messed up. It's the other reason I'm so obnoxious about where is the base. So the 2B represents the area of both bases, in this case, again, triangles, noticing that I'm using the triangle formula, the triangle area formula. And then we're finding the area of the lateral faces, which we just talked about, were rectangles, right? So I could find each one separately, find the sum of them by finding each separate rectangle and adding them up, which a lot of you guys did on the Jamboard. It was excellent. Or the formula suggests, well, great, but what else you could do, especially when it's not necessarily triangular anymore, maybe it's a decagon, maybe the base is a 52gon, instead of finding 52 separate rectangles, go, well, isn't the base of those rectangles the perimeter of the base? So adding all those up collects the bases of all those rectangles, regardless of how many sides your base has. And then as long as you're multiplying all of them by the congruent height, which is always the distance from the base to base. Again, this dude's taking a nap. That's why it's 11, not 3. The height, if I take a nap, is not suddenly from my belly button to my back. It is from head to toe. Then you will collect, this is the lateral area. These are just the rectangles. These are just the bases. Add them together. You've got your surface area. So how does that work here? Well, first of all, let's check this out. Big B stands for the area of the base. So the first question I always ask is, what is the base? What shape is the base? Well, for a cylinder, the shape is a circle. And you should recognize that that is the area formula for a circle, right? That's why the pi r squared is there. So these are identical. It's just saying specifically for a cylinder, the area formula I'm always going to use is pi r squared, because the base will always be a circle. Big B can change to whatever for a prism. If it's a triangle, it's going to be the area formula for a triangle. If it's a regular polygon, it's going to be the area formula for a regular polygon. Cylinder, there's only one shape it could ever be, pi r squared, which is why it's getting its own separate formula, but still exactly the same as the previous one, just being specific. The perimeter of the base times the height. This was to find the base times the height of each rectangle. Well, with a cylinder, there's still a rectangle involved, but it's just that there aren't a bunch, there's just one. So that reminder that if you take the, like if it's like a can, you open the can from the top, the bottom, those are your 2 circles. And then if you cut the that last face apart and unwrap it, you're gonna get a rectangle. So that rectangle is still the same, you know, the formula for a rectangle doesn't change. It's still base times height. And if you just want to think of like a real life example, for those of you that have water bottles with like the plastic, a lot of people rip it off and play around with it. It's always a rectangle. Labels on cans, all that stuff. But now this rectangle is a different rectangle because the height is not that exciting, right? Height's from base to base. It's from circle to circle. It's how tall this can is, right? But the base of it is very, very, very dependent on its base. So if you really pay attention, I'm going to just do this a few times for you to think about it. Ooh, just let me press play. Ooh, that's not fast enough. Oh, it's fine. Think about what the base would be, thinking about what part of the circle that base is hugging. Okay, oh, this is too slow. I got time for this. So when you unwrap that lateral area, this whole base came from the circumference of the circle. So the base is the circumference of the circle that you've unwrapped it around. So it was around the base circumference, and then when you unwrapped it, that's still defined by the circumference of that circle. So that's where this part comes from. Pi dh, we know pi d. Pi d is the circumference of the circle. That is the formula for the circumference. I wanted to find this, it would be pi d. The h part is the height of the cylinder, right? So the height of the prism is from base to base, same for a cylinder. So cylinder prism, exact same formula. This one is just reminding you that there's a little, we got to be a little more specific because circles are involved. Big B will always be pi r squared for a cylinder. And the base of the one rectangle you have, which is the lateral face of your cylinder, is always going to be the circumference of the circle. But they are still the same idea. Now let's see how triangles come into, triangles, yeah, come into play. So this is the other part. First of all, when we're dealing with a pyramid or cone, there are two different types of heights. And there's a really good way to remember it too that I think a lot of you will be fine with. When we're talking about the height of something, it's always the perpendicular, right? So the height of this pyramid would be from the vertex straight down. That would be h, the height. Now, when I would use that height, let's see, where does that height exist? Inside the pyramid, inside the cone. So guess what? I'm going to use that height when I'm trying to figure out stuff about the inside of it. Volume, right? I'll need the inside height when I'm looking for inside stuff, like how much sand to fill, water, whatever your idea is. Now, if we're talking surface area, though, I need the surface height, right? I need the height on the surface. We also call that the slant height. So this is the other way we say it is L, the slant height. And again, you're going to see that in your, oh, we don't need this right now. We're going to see that in your formulas, L. So there's a difference between L and H. H is inside, straight string drop through right through the center. And then L is the surface one. Because remember, if we're thinking about surface area as the area of the surface, if I undid all of these shapes, I would just be pasting 4 triangles in 1 square. Well, I need the height of that triangle. The height of that triangle isn't inside our 3-dimensional shape. It's the slanty part, right? So if you look at this formula, you should start to try to make connections. First of all, big B, look, there's only one of them. Why? Because there's only one base. So big B will be swapped out with whatever the shape is of that base. So this is a square. So the big B in this case, and it should say that this is a square pyramid, but it doesn't, so sorry. So big B, I'm going to replace with base times height. Or you can also do S squared, right? Because that's big B. And then in this case, I'm just going to do each part, base first and then the rest of it. 4 times 4. And then so that means big B, the area of the base, in this case is a square, is 16 centimeters squared. And then this part. So again, for a prism, it was the perimeter of the base times the height, because this was based on the area formula for a rectangle, because the lateral faces were rectangles. Instead of just base times height, however many times, you're just collecting the bases. So let's see what's happening now. The lateral faces aren't rectangles, they're triangles. So it makes sense that this guy is based off of the area formula for a triangle. Base times height divided by 2, right? But then in this case, same idea. I'm going to collect the bases of my triangles. There's 4 of them, right? Isn't that the perimeter of the triangle? Oh, sorry, yeah, the perimeter of the base is the base of each triangle. So there's that part. But big PL. Sorry, that looks terrible. So the base perimeter is going to collect those for me. So 4 times 4 is 16. So the perimeter is also 16. 4 plus 4 plus 4 plus 4. And then notice the area formula for a triangle is base times height divided by 2. That's when we're talking a 2-dimensional flat on the wall triangle where the height, there's only one height. 3D land, we need to make sure we're using the proper height. Surface area, surface height. Surface height is that, we call it the slant height. So I don't need the height that's through the middle that I'll use like crazy for volume. I need this guy. So L is 7. And then divide that by 2. So again, this is collecting the areas of all the triangles. Okay, so 8 times 7 is 56. And that's how you'd find the surface area of a pyramid. And that's where it connects from. It's coming from the area of a triangle. And then obviously one big B is because it's the area of one base. Waiting for it. 72? My brain isn't working today. Is it 72? 16. Yeah? Cool. Thanks, everyone. I hope it is. Oh, because like, dude, straight up. I thought 8 times 3 was 28 all morning, so I'm out of it. So that is for a pyramid. Guess what? Cone and pyramid are related the same way that cylinder and prism are. So I'm just going to go grab from the packet a picture of a cone. Oh, hey. And this one, I also like these in your packet, which is really honestly for you guys to not take notes in, like, it's not like an algebra class. A lot of them are just there for diagrams for like, hey, do the surface area of that one, find the area of this one. So I might as well keep on this page. I'll just expand here. So this also is a great helpful in showing the difference between slant height and heights. The height is like from the top straight to the bottom. Slant height's on the slanty part. Also, little preview. Yes, the height and the slant height, as well as like the radius, if you're talking cone, or just the apothem of the base of a pyramid. Look at that, you got a right triangle. So if I need something that I don't have, you've got lots of friends. You've got special right triangles, 30, 60, 90, 45, 45, 90. You've got Pythag and you've got trig to help you if you've got one and need the other, and vice versa. But I digress. So here's a cone. Let's see. What happens when the first parts should make sense because the cone, there's one base, right? Just one. And in the case of a cone, that base, I should do this one. That base is a circle. So look at that. The circle formula, area of circle formula, blah, is the first part because that's big B. That's big B when we're talking about a cone. Pi or L, let's get to that part. Now, when you unwrap a cone, what does it look like? Bye, cylinder, love you. Change that height, boop. So that's the inside height, right? Okay, here's the net. So there's your big B, and you cut this, and it makes what I like to call a funky triangle, or a fancy triangle, a triangle with a skirt, whatever floats your boat. So this should make sense that it's big B. This is just big B, which is the area of a circle. And then this part, let's check this out. So when I undo this lateral face, gorgeous, gorgeous, funky triangle, it's still based off of the area formula for a triangle, right? So here's your height, but again, it's not this height, it's going to be the slant height. If I unwrap this cone, this height is right here, right? It's if I unwrapped it and then stuck it on a wall. So this is the slant height. The base of this circle, the base of the lateral face, same thing, should be making sense from that cylinder explanation. The base of this is the circumference of the circle. So let's stick these into the triangle formula. No, it's not a triangle, but it's the formula for this lateral face is based off of the triangle. The base is your circumference times the height, which is your lateral face, divided by 2. I'm going to give you a second to see if you can connect why these are the same. Because they are. I can speak normally. Well, here it is. Hi. If D is the diameter and we're dividing by 2, isn't that the same thing as the radius? Yep. So we can rewrite PDL over 2 as pi RL. So this is your lateral. This is that lateral, the funky triangle. That's the area of that one. Funky triangle. So that is how all of those, oh geez, those formulas for prism and cylinder are really the same thing. So I think of it as the formula for a 2-based solid, right? 2 bases, and then it's based off a rectangle versus a 1-base solid. 1 base, and this is based off of the area of a triangle. It's just that for a cone and cylinder, you have to consider how circles are very involved with the formulas.